Okay, so we're solving problems using variations. So we have to read very carefully. It says y varies directly with x. So that means y varies directly with x. Right? If x gets bigger, y gets bigger. And so if I wanted to solve for k and get k by itself, I would divide both sides by x, right? So k equals y divided by x. And that is why we said, oh, well, we can also solve problems using a proportion. If that's equal to a constant, that's equal to k. And then this would be equal to the same number. So I can set them equal to each other and write a proportion to solve problems. So now I'm just going to substitute in what I've got. I've got y equals 20 when x is equal to 4. So those go together. So I have 20 when x is equal to 4. And I know over here I want to find y, so I don't know y, when x is equal to 7. Okay, so then I'm going to cross multiply. So I get, oh, yeah, that's, no, I have x times y. What did I forget? Oh, I forgot to substitute for x over here. I only want to have one variable. So this was supposed to be when y is 20, x is 4. So I'll put that right there. Okay, here we go. So now 4 times y is equal to 20 times 7, which is 140. And then I'm going to divide by 4. So I get y equals, let's see, it will take 140 divided by 4. Oh, look, it's right there. 35. 140 divided by 4. Oh, goodness. 140 divided by 4. Okay, 35. All right, and that's what they were asking for. Okay. If I wanted to write my equation with now that I know what y is, well, let's see. What's my constant? If I wanted to know what k is, well, I just look over here. I've got 20 divided by 4, so that's equal to 5. All right, so 5 is my constant. So I could write this equation as y equals 5 times x. All right. So now if y varies jointly, all right, if y varies jointly with x and z, okay, so jointly you always are going to have 3 things. So I have y varies jointly, so varies, I got my constant, jointly with x and z. They're all in a line. So it's like the direct variation, but there's 3 variables. All right. And so what that means is if I wanted to solve for my constant, right, I would divide both sides by x and z. Right, and that crosses out and that crosses out. So I have the constant equals y divided by x over z. So I have y divided by x over z as my constant. So that's going to always be the same number if I have a joint variation. So I can set up a proportion to solve my problem. And then let's see what I've got. Look at my givens. Y is 10 when x is 2 and z is 3. So I'm going to substitute 10 in for y, 2 in for x, and 3 in for z. All right, and then on the other side, I've got find y when x is 3. So I don't know y, so I'll put a y. And I've got x is 3 and z is 5. Okay, so I have a proportion, right? And I'm just going to cross multiply. So I've got, let's see, 2 times 3 is 6, right? So I have 6y equals, and then I've got 10 times 3 times 5. So 10 times 3 times 5 is 150. All right, now I want that y by itself. 6 times y, so I'm going to divide by 6. right? And I get y equals, and I'll just take 150 and divide by 6. And I get 25. So y equals 25. And that's my final answer. If I wanted to write the joint variation, the model, it would be y equals, and then my constant, well, let's see, my constant is whatever this is right here, 10 divided by 6, right? Remember that was 10 over 6. All right, so let's see if I can reduce that. I'll go alpha y equals, enter, and I'm going to do 10 divided by 6. It does reduce. It reduces to 5/3. All right, so y equals my constant, which is 5/3 times x times z. All right, and that would be my joint variation if I wanted to write the model of it. And then this is if I wanted to solve for y. All right. So these, it just takes a lot of practice. All right, so we've done 2. So now, actually, let's do one more, so we'll have done one of every type, and then you can try the next ones on your own and come by and check. So if y varies inversely, all right, so y is varying inversely. So y varies inversely with x. All right, so what does that mean? That means y varies, so I have my y equals k, but it's inversely, so that x is in the denominator. If you have a cake and you divide it by 100 pieces, right, this denominator, if I divide that by 100 pieces, they're going to be really small, okay? So if I have a lot, my denominator is really big, then my number is going to be really small, so that's inverse. One goes up and one goes down. So if I wanted to solve this equation for k, my constant, to get my constant by itself, right, I would multiply both sides by x, right, because this is in the top, so that would cross out. Right? One in the top, one in the bottom, so that would be k equals x times y is equal to k. Right? Over here I have x times y equals k. So I can write my, if that's a constant, then they're always, x times y is always going to be the same. So I can set it up like that, and that's for an inverse relationship. All right, and then I'll go ahead and substitute what I've got. I've got y is 16 when x is 2. All right, so 16 times 2 is going to be a constant. And then I've got over here y, find y, so I don't know y when x is 8. All right, so that's what I've got over there. So 16 times 2 is 32. Equals 8y, right? If you're multiplying, remember that's commutative, so I can change the order. Now I'll divide both sides by 8, so I get y equals, and then 32 divided by 8 is 4. Okay? And then my constant here, remember, is x times y, right? K equals x times y. So x times y is going to be 32. So if I wanted to write the model for my inverse variation, I would write y equals, k is 32 over x. X goes in the denominator. All right, and so if it varies inversely, it's going to look like that. So go ahead and try number 4 and pause it, and then you can check it when you get back. All right, so for number 4, you have y varies inversely with x. So y varies inversely with x. Okay, and so that means x times y equals my constant. Right, that equals the constant, so I can set xy equal to xy. Right, because that equals the constant. And so now I'm going to substitute here. I've got y is 3 when x is 5. So 3 times 5 is going to be that. And then find y when x is 10. So x is 10, and it says find y. So it looks like that. So 3 times 5 here is 15. So we have 15 equals 10y, right? So I'm going to divide by 10. And I get y equals, I'm going to move my decimal over one place. So that would be 1.5. Right, so I've solved for y, and if I wanted to write the inverse variation, right, it's going to be y equals, oh, what's my constant? Well, the constant, remember, was x times y, right? That's equal to k. So that was 3 times 5, which was 15. So y equals 15 for the k over x. And that's what that variation would look like. An inverse variation. X is in the bottom and y is in the top. Okay, so again, pause it, try number 5, and then come back and check it. So y varies jointly with x and z. So that would be y equals, oops, I forgot the k. K times x times z. Right, they're all in a line. Okay? And if I want to solve for k, I'm going to divide by x and z. Divide by x and z. So these cross out, and I have k equals y over x times z. Y over x times z. That's a joint variation if you have 3 variables. So I wrote my proportion, and I'm going to substitute. So y is 50. These are the 3 numbers that go together. So y is 50, x is 6, and z is 5. And over here I have y that I don't know, so I'll just write y. X is 10, and z is 2. Okay. So then I'm just going to cross multiply, right? And so 6 times 5 is 30. So I have 30y equals, and then I've got 50 times 10 times 2. So 50 times 10 times 2 is 1,000. And then I'm going to do the inverse, right? And divide both sides by 30. So y is equal to 1,000 over 30. So I'll just divide that 1,000 by 30, and I'll get 33.333333, which we've done that a few times. So that is 33. It's good to memorize. That's 33 in the third. 1333333 is 1/3. 0.666666 is 2/3. Alrighty. So very good. Oh, so now if I want to write, go back and write the model, I would say y varies jointly. So what's my constant? Oh, let's see. That would be the y over xz. So that's this, right? 50 over 30. So let me see what that is. I'm going to go alpha y equals, enter. I'll do 50 over 30. That's 5/3. So my constant k is 5/3. Y equals 5/3. That's k, and then you have your x and your z. All right, and that would be my model equation for the joint variation. And then actually solving the problem, that was why is that. All right, so again, go ahead and try number 6. Hopefully you're starting to get the hang of it. Oh, great. Okay, let me pause this. Okay, so here we go. Y varies directly. So y varies directly with x. So y varies directly with x, right? So if I solve for x, or excuse me, solve for k, right? The x is crossed out, and so I get y divided by x equals y divided by x. Directly divide, directly divide. They both start with z, okay? So now I have my variables, so I'll go ahead and solve it. I know that when y is 2, x is 8. And here I don't know y, but I do know x is 24, so you substitute. I go from my proportion to substitute, and then now I'm going to write an equation by cross multiplying, so I get 8y equals 2 times 24. So 2 times 2 is 4, and 2 times 8 is 8. So there we go. And then now I'm going to divide by 8. Divide by 8. So y equals 6. And then now if I want to come back and write the equation, I'd say y equals 6. That's the constant. Or no, that's not the constant. That is not the constant. Y equals, what is the constant? Remember the constant, k equals y divided by x. All right, y divided by x, that's my constant. So over here I have 2 divided by 8. So let me put that into my calculator. So alpha y equals, enter. I have 2 divided by 8. So my constant is 1/4. My constant of variation is 1/4. And then I have x. And that is my direct, remember that's a direct variation. They're all in the line. X goes up, y goes up. All right, so now let's check out these questions here. It says determine which type of variation exists. Okay, so try them out and then come back and we'll see how you did. So for this one, I have y here and x in the denominator. So that tells me that's an inverse. That's a weird way to write inverse. That's an inverse variation. Right, these are all variations. Inverse variation. And this one, it looks inversely because there's a number in the denominator, right? But it's not a x is not in the denominator. It matters where x is. X is up here in the numerator, right? They're both, y is up in the numerator, so if x gets bigger, y is going to get bigger, and that would be a direct variation. Okay, this would be this 1/4, 1/4, that would be your constant. K is 1/4. Your constant of variation will be K. Here, going back to number 7, is 10. That is your constant of variation, would be 10. Right? And then notice number 9, we've got y and x and z. So that is a joint variation. That's the easiest, I think, because it's the only one that has 3, right? So now here we have this one. I've got x times y equals 3. So x times y is always going to equal 3. All right? So if you're not sure what that is, you can get y by itself. If I divide to get y by itself, I get y equals 3, a constant, over x. So that would be inverse variation. All right? Because remember, to find k for the inverse variation, remember we always multiply. For inverse variation, you multiply x times y. All right? Very good. Okay, and now for 11, that's kind of hard to tell, except how many variables do we have? We have 1, 2, 3, x, y, and z. So my first guess would be that it would be a joint variation. Well, let's see, if I try to get y by itself, I would multiply by x, because x is in the denominator. Anytime you want to get rid of a denominator, you multiply by it. So that would be 2y equals, and I'm just going to write xz, right? Remember, the commutative property can change the order. And then I'm going to get 2 here by itself, the y by itself. So y equals x times z, all right, divided by 2. Well, that means my constant, my k, actually is a fraction. It's 1/2. Okay? But yeah, that would be a joint variation. That's a joint variation because I have x, y, and z. Okay, very good. We'll stop that there.